Okay, so for my AP video tutorial, we're going to do a level 5 question over acids and bases. So, the question says, hypochlorous acid, HOCl, is a weak acid commonly used as a bleaching agent. The acid dissociation constant, Ka, for the reaction, right there, is 3.2 times 10 to the negative 8th. So, first question, calculate the H plus concentration of a 0.2 molar solution of HOCl. So, over here we have it solved out. So first, you know your Ka right over here. It's going to be your H plus concentration times your OCl concentration over your HOCl concentration, and it's going to be equal to 3.2 times 10 to the negative 8th, as it says over here in our equation, or in your initial conditions. So first you're going to take a Rice table. So you have your reaction written out right here, and then I is going to be the moles. So this one, it was initially given to us, your molarity. So you're going to have 0.24 molarity. So you're going to plug that in, and it doesn't say anything about the other two, so you're just going to put 0. So the reaction is going to need to shift to the right. So you're going to subtract x from the left and add x to both of the right sides. So your equilibrium is going to be 0.24 molar minus x. And then you're going to come down here and you're just going to plug all of this back up into your equation up here. So you're going to have your Ka of 3.2 times 10 to the negative 8th equaling to your equilibrium concentration of H and OCl, so it's just going to be x times x, or x squared, and then your equilibrium concentration of HOCl, which is going to be 0.24 minus x. And you can just negate the negative x right here because it's not going to make much of a difference because you have 3.2 times 10 to the negative 8th, so it's too small of a number to really make a difference. So then you're going to come over here, and once you solve that out for x, you just multiply this, because you're ignoring the x, so you're just going to multiply the 3.2 times 10 to the negative 8th times 0.24, and then take the square root of that to find your x value. You're going to get 8.76 times 10 to the negative 5 molar is going to be your x. So, because the concentration of H plus is simply just x, that's going to be your concentration down here, and that's what you're looking for. Alright, so for B, write the balanced net ionic equation for the reaction that occurs when NaOCl is dissolved in water and calculate the numerical value of the equilibrium constant. So, over here, we're going to have NaOCl plus H2O, like it said, and over here we're going to have Na plus HOCl plus OH negative. So you're going to start out, and your Kb is going to be equal to your Kw over your Ka. So we know our Ka from up here is going to be 3.2 times 10 to the negative 8, and your Kw is just going to be 1 times 10 to the negative 14. And then whenever you divide this, you are going to get 3.125 times 10 to the negative 7. And there's your answer. Alright, so for part C, on this side. So for part C, you're going to calculate the pH of a solution made when 40 milliliters of 0.1